3, 2, 1.
The submarine photographed in the filming of K-19, the Widowmaker, was an actual Russian sub. The Juliet 484 was modified to look like a Russian hotel-class submarine. After filming was completed, it was towed to Collier's Point Park, just over a mile from the center of downtown Providence, Rhode Island. The Juliet 484 was known in the Soviet Navy as the K-77. Its keel was laid on January 31st, 1963, with a length of 281.75 feet and a beam of 31.2 feet. The boat was launched on March 11th, 1965. Juliet-class boats were designed to carry 4 nuclear-armed cruise missiles, which were housed in tubes that had to be raised to fire. A powerful target guidance radar, measuring more than 100 square feet in area, was built into the forward edge of the sail structure. The radar can be seen in its deployed state, which opens by rotating 180 degrees. In order to fire their missiles, it was necessary for the submarine to surface. The actual process of arming and firing the weapons took as much as 14 minutes while surfaced. The submarine was then forced to remain exposed while it provided the missiles with targeting information from the ship's own radar during their flight. Her low magnetic signature hull was covered with 2-inch thick hard rubber tiles. The K-77 ran on diesel and electric motors. With its 2 screws, the boat attained speeds of 16.8 knots while surfaced and 18 knots submerged. It could remain underwater for 800 hours at a time, descending to a safe depth of 775 feet with a crush depth of 1,200 feet. It carried a standard load of stores for 90 days. The mission of Juliet-class submarines became to destroy United States aircraft carriers at sea and, when possible, in port. Juliet-class submarines were withdrawn from active service beginning in 1988. The K-77 was decommissioned sometime between 1991 and 1994. By the end of 1994, all Juliet-class submarines had been removed from service. The K-77 took on the name of Juliet U-484, derived from a metal plate that was discovered inside the boat. It was determined that the plate and others bearing different numbers were affixed to the submarine's conning tower during surface running to confuse NATO reconnaissance aircraft as to the identity of that particular submarine. The Russian Submarine Museum was formally opened to the public in August 2002. For more information, check out the sub's website, www.juliet484.org.
Hi Ray, I'm Chris Gamley. I'm from Brooklyn, New York. It's my first time at the actually bringing a model to the Sub Regatta. I came last year and I just had to build one. This is a model of a 1/48 scale model of the USS Blueback. She's the last surviving diesel-electric attack submarine that the United States Navy built. Her sisters, the Bonefish and the Barbel, have been scuttled and dismantled, and she's currently in a museum in Portland, Oregon. This hull is manufactured by Britt Boyette. He lives in Oregon too, and I had purchased this off of Joe Swanee, and Britt was kind enough to help me finish her out since I can't. I live in an apartment in Brooklyn, and with 2 kids, my wife says no to Bondo and no to paint. She basically has a D&E 3.5 watertight cylinder in here off system, with a Roby speed controller off a standard 540/05 12-volt motor through a 3-to-1 reduction gear. Just a few little modifications to it that I did, just rescribing it and putting some additional scopes on the sail as per some pictures I got from Sea Photo and from the OMSI Museum in Portland, Oregon. So I haven't even tried her out yet, so I'm looking forward to trying her out. Britt puts a lot of the scribing on the deck when the boat was in dry dock back in '98, and since he lives very close to the actual submarine, the detail is as much as close to possible. I just made it a little deeper and so forth to let it come out a little bit more when he painted the boat for me. I actually shipped it back to him because I couldn't do it. And on the underside, the detail is more exact because when she was in dry dock, he was able to go underneath the boat and actually, take shots and so forth. So this is a very detailed hull if you were to get one, and I was very happy with the product and so forth.
Hi, my name's Bill Marks. I'm from Stratford, New Hampshire. This is a model of the USS Barbel, the lead ship of the Barbel class diesel-electric submarines built. This one was built in Portsmouth, New Hampshire in 1957-58. The hull was built by Brian Boyette out of Oregon, and other than the fiberglass hull, I built the rest of it. As far as I can tell, it's an accurate reproduction. I was chief engineer of this boat from '72 to '74, and XO of it, executive officer of it, from '77 and '78, and got an opportunity to take it to sea as commanding officer for a while when the commanding officer had a medical problem. Inside, it's a little different than most of the boats that you'll see here today. First of all, it's a much bigger watertight cylinder. It's a 5-inch watertight cylinder. And it uses a gas ballast system. Underneath here, there's a can of R134A automobile refrigerant. It's ozone friendly, and it is used through this line and valve to blow the ballast tank dry. Because it weighs quite a bit, I can use 14 ounces of it over a season. I actually have a little compensating tank that as I use gas out of the can, I add water into this tank to make up for the weight difference. Ballast tank uses 2 solenoid valves for vent valves, allows it to dive in about, it can go down to fully submerged in about 10 seconds. And in the watertight cylinder, it's 5 inches in diameter, homemade, and uses a 6-channel radio. And I just had it out for a dive, and it just performed absolutely beautifully until I got some seaweed into the propeller. Also, I've got 2 big lead-acid batteries that sit down here very low in the boat, gives it a lot of stability. The R's and the B's and the A, if I have to take components out, because the placement of the foam is there to compensate exactly for each of the components, like valves and the weight of the can and stuff, I have to put them back exactly where I took them out. So it's like a jigsaw puzzle. And I have a drawing at home that says, A goes here, B goes here, D, and so forth. One of the things that people that aren't familiar with these submarines might think is unusual, particularly the model airplane flyers, is they can't understand that the antenna actually stays underwater the whole time.
Hi, I'm Rob Cade. I live in Groton, Connecticut. Recently moved up. I've been in RC planes and helicopters a long time and wanted something a little bit friendlier and more fun. Hooked up with some guys that do subs. This is my first sub. It's a 172nd permit. I've been working on it for about 3 months now, and probably have another month's worth of work to do. Got a WTC, I've got automatic leveling control, a missing signal detector to bring it up if it runs into trouble. It's going to have a 12-volt battery up front to drive the motor. I have a gas-saving device in my ballast tank and propel canister here. One of the things I did that was kind of neat is it didn't have indexing strips. So when I cut the hull, I came up with the idea, I used the hull shape on top to make the indexing strips, and then to actually get them into place and fit right, I tack glued them, epoxied them with 2-hour epoxy, and then I stuck a balloon through the shaft opening in the back. When I blew the balloon up, it pushed the indexing strips out into the hull just where they should be. Then when it, after the epoxy dried, I let the air out the balloon, and my indexing strips came out just perfect. So it's a perfect match now when I assemble the hull halves, which was kind of a different idea, I guess, but had a lot of fun, and looks like we got a real good crowd, and looking forward to wandering around a little bit and getting some ideas from other folks.
You may remember me from last year as Ray had my Type 21 kit that I produced and had here with me. Since then, I've made an add-on to the Type 21. I have now the Wilhelm Bauer 1967 version. It's on the Type 21 hull, but the conning tower and the cubas and a lot of the deck detail, of course, relates to the 1967 version of the Wilhelm Bauer. As Ray's taking pictures here, we're getting some good views of the 67 version of the Wilhelm Tower and conning tower. There's a lot of changes, difference. The hull's the same, but there's deck configurations that are different. The stabilizer wings in the stern are different. Rudder, of course, and dive planes are identical. Same with the bow planes are identical to it. And some of the openings on the side of the hull, as well as the deck, are a little bit different than what comes with my Type 21 kit. So this is just what I call an add-on to give me a second kit, the U Wilhelm Bauer.
My name is Joe Angie. I come from Mount Kisco, New York, and I'm building, or I just finished building, the Roby U47. This one is dubbed the U48 because we've made quite a few changes to it. Starting with the Engel ballast tank system, which a good friend of mine, Clive Wadsworth, has helped me greatly install. This is a modification to the original. The batteries in the stock boat fit from here to here. So I've put 2 6-volt nickel metal packs in lieu of the big batteries that were supposed to be there. I've also changed to geared reduction for the motor drive. These were from Subtech. Originally I had put a Subtech motor in there, but they were designed for 12 volts, so I went to a Speed 400 rated for 6 volts. I also modified a third servo so that I can operate the bow planes from the radio instead of the stock Roby system, which used a dynamic system to move the front bow planes. Other minor changes throughout the boat. I moved the bellows to the inside of the pressure hull because the angle system causes an extra or an overpressure inside the pressure hull. Found a little less leakage problem through there. As a matter of fact, there's been absolutely no leaks in this boat, at least as of yet. Other modifications have been up at the front of the boat. The Subtech APC-3, which runs the rear drive planes. The whole boat slides together nicely. It's held together with a central screw joiner from the front. Really ingenious design. It was fairly difficult to build. It took about 200 hours to get to this point, and this is still in primer. It is not done yet.
I'm Jonathan Eno from Hulls Cove, Maine, and this is a model of USS Nautilus, SSN 571. It's a hull that's produced by Dennis DeBoer of South Dakota. It is 1/48 scale. I chose to make this a dry hull boat, and so I put the ballast tanks inside, very similar to Johan Sauer's. I use a CO2 compressed air ballast system. This is a ballast solenoid. Just aft and flanking that are two servos that control the bow planes for deployment and for angular change. And then tucked aft of that is an automatic leveling system that comes from a fellow in Germany that Johan knows it. And then moving aft into the next compartment are a pair of speed controls, the servos for rudder and dive planes, and then we have the main drive motors from Harbor Models, which are large Pitmans, and then the aft ballast tank, ballast solenoid, and then outside of the pressure hull are gel cell batteries. Aft is a 4 amp, and then forward is a 4 amp and a 7 amp. The dive plane mechanism got a little complicated on me because the planes deploy more than 90 degrees, and because they interfere with the pressure hull when they are deployed. Normally when they're deployed, as they deploy outwards, the pressure hull would interfere with them. So by moving things around a little bit and finding that the pivot point is different, the planes actually go through an arc when they pivot.
Okay. Level them out.
I can pull the entire valve system out.
That's it.
Nautilus is a museum ship up in Groton now, but getting information on Nautilus is very difficult because she's still classified due to Admiral Rickover. There are plans available from Tubman, which is what I used to work on this. Anyone else who has information that is willing to share, it's always helpful. Otherwise, you're shooting in the dark a little bit.
My name is Bob Dimack, and this is the OTW Seehund 1/9 scale German midget. It's our latest product, and it is 53 inches long. As you can see, it's camouflaged, and people sometimes say, why does the camouflage only come down so far? The crew used to camouflage them actually in the harbour. So that was the waterline, basically. I'll just take the top off. You can see what's inside. Inside we've got one of our dive modules, and we've revised our dive module, so we're using a pump system. We're pumping water. This is the dive module. It's a 3-chambered acrylic tube. We've got a water pump here which is reversible, which is connected to a hydraulic valve, so that when the pump is open, the valve is open. When the pump stops working, the valve closes. We have a pump management system here which allows you to forward and reverse the pump. It's also got 2 fail-safes. If you lose radio frequency, it'll blow the tanks, and if your battery capacity goes down to 8 volts, it'll also blow the tanks. We've got probes here in the actual dive module. If the water hits the top probe, then the pump shuts off. The air that is displaced from the ballast tank leaks through a tube here into either end and is stored at about 6 psi. So to dive the submarine, you pump in the water, you submerge. To surface, you reverse the pump and blow the water back out. And at this end, we've got our drive motor with a waterproof coupling. We've got 2 push rods here with waterproof bellows to operate the hydroplane and the cord nozzle. And we've got a speed controller here which has a beck on it, which means you can run the whole 9 yards off a 12-volt battery, and that will convert the 12 volts into the 4.8 that you need for your servos and your receiver. And as you can see, it fits quite neatly into the boat. It's actually held on. I won't connect it, but it's actually held in position with a brass strap. These rods at this end are connected to the control surfaces. You see we get they're the hydroplanes and the cord nozzle. So that's it. I won't be a second.
I'm so taken by this.
Thank you.
What a level you guys brought us about.
Yep.
Oh. All right, so do you want to give me a little walkthrough?
Yeah, sure. We've got a finished version here of the OTW Type 7, and you can see all the detailing on the hull. That is how the hull comes, with all the detail. You've got a photo-etched brass deck, so you don't have to cut out any of the slots. Everything's done for you. We've got a glass fiber conning tower here. This is the alternative to the standard brass conning tower. And as you can see, it makes up to a very nice model. At the forward end, we've got brass plane guards with the dive planes. And we move down the deck. You've got your gun, all the bits and pieces that you can see. Inside you can see the stern end of the dive module, which is very similar to the one that I've just talked about with the Sea Hund. And at the stern end, we've got the twin propeller shafts, left and right propellers, dive planes and rudders. Now, to give you some idea of what you get apart from the hull, we've got 2 full brass frets here. This is how your deck comes. So you can see how the deck comes, and you've got your sides of your conning tower here. If you notice, the deck is textured as it was on the full-sized boats. Right, we've got the running gear here for the Type 7. You've got left and right propellers, cast A-frame complete with phosphor bronze bushes, front plane guards, and rear drop skeg. These are the propeller shafts. They're made out of stainless steel, 4 millimeters. You've also got an outer shaft here which is bushed at either end with phosphor-bronze bushes. These are the bits, the rudders and front dive planes and hatches, front magnetic compass housing and rear dive planes. They're all cast in polyurethane resin with stainless steel shafts, and they all come with their own phosphor-bronze bushes as well. And to finish it all off, these are all the bits for the periscopes, guns, net cutters, in fact the whole 9 yards. And if you think that you can't make the brass conning tower, we can supply a cheat. It's a glass fiber conning tower, which is a lot easier to work with. The kit is 1/32 scale and is just under 7 feet long.
Hi, my name is Dick Bernier. I'm from Mebane, North Carolina. What we have here is one of Bob Wallace's World War II Japanese-type suicide subs. I've been in with the subcommittee about 5 years now, and lost one sub, and this sub here was started and detailed out for us by Dave Merriman down in Virginia Beach. He finished it for us last week. We picked it up, we ran it over at Lake Trashmore for a few days and brought it up here for its maiden runs, and it's been doing very well. We still have a little bit of more trimming to do on it and a little more detail work, and it'll be finished in about 2 or 3 weeks. And I can show you the inside of it. The outside of it's been very well done by Dave, putting some of the algae on it and some of the weathering. It's got one of Dave's cylinders in it, which I've had that for a couple of years. I've had the sub actually for 2 or 3 years, but just got around to sending it over there to get the thing done. Mainly because I've been too busy like everybody else. Very good runner. We're really pleased with it. I got a friend of mine here from Waterbury, Connecticut, who was running it on the surface today, and it's the first time he's been running a submarine, and he did very well with it.
My name is Jeff Groseth. I'm from San Marino in California. That's near Pasadena, where the Rose Parade is. I have a Subtech albacore here that I built with the X-Tail. This is my second time at the regatta, first time running, trying to do the course, which is very difficult. At that point now, you can operate your boat. We have an obstacle here. We have a big battleship. I'm going to go around behind you.
Hi, I'm Skip Acey of Subtech, and this is our new kit, our latest kit, the USS Marlin, a 1/35th scale version of the USS Marlin SST-2, which was a research and training boat. Matter of fact, Marlin still exists. She's on dry land in Omaha, Nebraska. This particular boat, as I said, is 35 inches long. It's all vacuum formed styrene, as the albacore, our first offering. And as you can see, it's quite a bit different in shape. As a matter of fact, it's different from most submarines. It's certainly not a teardrop-shaped boat, as so many others are. Marlin also features bow planes, which most other teardrop-shaped boats don't have. But then the neat thing about Marlin is it uses the entire albacore pressure hull system, which means you really don't have to reinvent the wheel. Let me pop the top off here and show you quickly inside. This particular model here is actually our prototype. We're doing a lot of testing with it. And this includes some stuff which is not normally included with the kit, but it also shows what can be done with it. All of the equipment inside is right straight from our catalog. Starting in the bow is the PBU, the Propel Backup System. This has an automatic depth control, the nickel metal hydride NMH27 battery. Obviously it's an Airtronics receiver, the APC3, the ballast pump, battery eliminator, and then of course the drive system itself. Most of those things come with the kit in one form or another, whether it's the basic kit, the basic package, or the deluxe package. Everything from this point back is all included with the kit. Please excuse the prop shaft housing. This is a prototype. The kit supplied housing will be, of course, one piece. It comes with a cast brass prop, molded control surfaces, outboards. A great deal of the details that are on top are not all of the details. The hatches, the sonar head, radar, and various and sundry other, of course, the whole anchor housing. These are all going to be standard parts of the kit. Since we'll be using square tubing as shafting for the bow planes, this always guarantees that when you put the bow planes in after you've put the deck on, that they're always going to be correct. Because if they're not correct, they're going to be 90 degrees off. It'll be very obvious. Obviously, that's not going to work.
My name is Chris Klepsch. I'm from Milton, Ontario. Belong to Subcom On, also a member of the subcommittee. The boat you see here is a Type 2C. It's built after U-62, as it was used as a school boat in 1943, 1944 under Oberleutnant Schlevogt. That's why you see the markings on the tower. They did change with different commanders. The actual boat was scuttled in 1945 in Wilhelmshaven, 2nd of May. The model itself, the hull, the casing, and the conning tower shell were purchased from Dave Manley in San Diego. He also supplied the dive planes and the rudder, as well as the body for the stern light. Everything else you see is scratch built. The figures are Tamiya. They're modified as a U-boat crew, Pudelmützen and all. There's just one bolt that holds it all together. Just slides off.
This detail here, this is the way it is.
There's the interior of the boat. Everything is scratch built. Start with the front. Okay, it has a working torpedo tube at the bottom of the boat. The other two I had to seal off because I needed the room to place the foam. Right at the center, bottom center. The top ones I had to cap off, close the shutters because I needed the room for foam to offset the weight of the batteries to trim the boat properly. I did have doors on at the top at one time, but I had to remove them because, like I said, I was running out of space. The torpedo tube is to fire torpedoes is made out of plastic tubing, and I used an old solenoid to release the torpedo. Next to it you see two 6-volt batteries, one standing up, one lying down, hooked up in series to give me 12 volt to operate my system. The ballast tank is made out of 4-inch Lexan tube. There is another gas container built into the Lexan tank, into the ballast tank, that holds the propel so I can dive and surface the boat. The components used to blow and vent the tank are from Subtech. The next you see, oh, there's a set of contacts here. This is to operate my deck lights, my running lights. I only need 2. I had 4 installed because I used one of the lights in the safety buoy for my water detector, which I had placed in the pressure hull. But due to space limitations and all the lead I had to put in here for ballast, I had to eliminate the water detector. So I hooked this light up to the running lights, just in case if the boat ever decides to settle in the cellar, I may have a little light source looking down on it. Going through here, you see a Novak speed control, which has worked flawlessly. The radio is a 6-channel Airtronics. APC I modified. It's an APC-1, an old unit, works beautiful. There's a soundboard for diesel sound, which was made by Robbie, and my failsafe is a RAM unit. There's a 9-volt battery beside it. It's a nickel metal hydrate to power my lights and my sound system. As you go further back, you see 2 500E Graupners, 3-to-1 gear reductions, running 2 stainless steel shafts which were made out of stainless steel wires, 3/16. The speaker itself is enclosed in a plastic capsule. That's the speaker right here. And in order to get to your seals down below for your shafts, you can actually pull the speaker, just plugs in. This is a connector from an automotive harness. This is a piece of an old suitcase, little plastic cup, which I sealed the speaker in, closed it off with a lid from a coffee cup, used some goop, some CA glue, and just plug it in, turn it on, it works. Removing it allows me to get at the seals for the drive shafts as well as for my dive planes and the rudder. These are just hardware items and containing O-rings which are easy to replace in case you do have a problem. This thing just goes right back in here and you're ready to go. The linkages, I had to support them here to take the flop away, and there's been no problem. The stern assembly, it's all made out of brass sheet, cut out with a pair of snippers and then straightened out and a bit of shape put on with automotive body filler. Brass streamlined tubing, reinforced by wires inside, brass wires as well as brass wires here. A screw soldered on here, a brass bolt soldered on here and the other side as well as on here. So if I have trouble and have to do any maintenance to the assembly due to bending or whatever, harsh handling, I just take these screws out, pull my dive planes out, remove the rudder, comes off very easily, disconnect my joints from my motor to my drive shaft, pull the shafts out and just drop the whole assembly by removing the 3 nuts. So everything is easy to fix if you had to. The detail is pretty well all handmade. I used documentation, books, photographs, a set of plans from Gary Beck, as well as the book published by Cole in Germany and their drawings to come up with the detail that you see here. Like I said, the crew is Tamiya, and the safety buoy started out as a ping pong ball. It's all hand lettered. The boat hooks actually lift off. You can just lift the hinges. The pin pulls out and the hook can be removed. The hook itself is made out of brass. These are barbecue bamboo spears, shaved down and then stained. The bullets can be raised manually. I do have a wrench. This is my toolbox. You just pull them up and twist them, all 4 of them, front and back. The detail you see here is made with glue and a syringe, white glue. And the same like the rivet detail is all done by white glue with a syringe. The nice thing about it is that if you don't like what you're putting on, take a finger and just wipe it off, start over again. And once you seal it in with your paint and your flat clear, it does not wash off. The deck itself is made out of Formica or Arborite, which they use to line to surface kitchen counters. And I've got the material from a kitchen counter from a cabinet shop. And I drew out the pattern under the Formica, drilled the holes in a jig on my drill press, and then used the file to open up into slots. My jumper wires, instead of using real wire, because if you do hit it, you're going to knock off half the detail, I decided to use elastic. The insulators were done with, they were actually buttons of a woman's blouse, modified, and all the little hooks and connectors are all made out of brass, and the whole thing put together, and a bit of paint and a bit of this and that, and that's what you end up with.
Take a walk around. Tell me about the gun.
Okay, the gun itself, it's a few bits out of the scrap bin, some styrene, aluminum, brass tubing, glue, wire, and a good set of drawings and photographs, and that's how I came up with this piece, 20 millimeter. It actually has a locking bar down here, which was a little pin. It will fit right into this hole. You can actually lock it, but because some people tend to try to swing the gun, I don't want to get this damaged, so I just leave it disconnected. The tower detail, again, photographs, publications that I could find to give me detail, and the hatch cover again started out as a ping pong ball. The ladder is brass, and you can, when you close the hatch and submerge the boat, the minute it becomes decks awash, that captain leans forward and disappears behind the rim of the tower. And as the boat comes up, he stands up again and he is there to be seen from shore. Well, everything else, like the flag, and it's all handmade, all scratch built. Going further back, it's pretty well the same thing. The rear casing, it's again white glue, just like the front, just like the rivets. And well, should these slacken off a bit, you can just take it in down here, shorten the elastics, and it'll be good for a few more runs.
If it works, as it did yesterday, I'm planning to launch a missile from the bow of this Los Angeles class submarine by remote control. And it's in the missile launching tube now. We're just going to try to launch it.
Servo will fly, right?
Servos, yeah, correct. 4, 3, 2, 1.
Awesome! Right where
it worked.
Wow. It went in the water right there, I can see.
All right.
Is that a number when you hit the
Might as well save it if I can.
Hold it up to the camera.
Hold it up to the camera, take the seaweed off. And it's nothing but a brass tube that fits on some something similar to O-rings on. And it's projected by carbon dioxide gas. And a rubber eraser nose cone. Sharpened and pencil sharpened.
Do it again.
And for those of you who've been with us for the past 10 years, you know that we've held our event at the sub base in Groton, Connecticut. Because of security measures, we decided to change our venue this year, and the city of Johnston, Rhode Island has stepped up to the plate and really done a great thing for us. They've done a lot of preparation on the park and on the lake here, and Miles Yancey would like to present a plaque of appreciation to the Assistant Director of the Parks Department, Lou Parada. I didn't give you a promotion or anything, did I? Okay. Assistant Director of the Parks Department, Lou Parada. And he's accepting on behalf of the Director of the Parks Department, Dan Mazzula, and Mayor of Johnston, William Macera. Thank you very much, Louis, and thank the boss for us. In the first category, we'd like to give out the prize for static modeling, and that prize goes to Edgar Arnold. Ed Arnold, where are you? You've won yourself a plaque, a prize. First place, static modeling for a model of a Soviet Alpha-class submarine in 1/700th scale. That's about that big. My eyesight's gone past that. Radio-controlled navigation. Boy, this is sort of like the happy times in the North Atlantic for the Germans back in the early 1940s. Third place in a Type 23 U-boat manufactured by 32nd Parallel is, I think, our first woman driver, Diane Ventrello, our second woman driver. Diane Ventrello, you've won yourself a prize for submarine driving.
Thank you.
Congratulations, Diane. Her first time at a subcommittee event driving a submarine. Third place. Second place in a Type 7B U-boat. This is one of the kits that you can buy. It's almost a turnkey submarine. You can get it from Ships and Things. Joe Angie for driving his Roby U-47 in the second place. Joe Angie. Congratulations, Joe.
Blow up, Joe. Blow up.
Radio control navigation. First place, the best sub driver this year's head of the class, and another German U-boat, a Type 2C, and that's Eric Klepsch. Eric, where are you? You've won yourself a nice prize. Beautiful plaque, and we admired your skill in getting around the course. Radio control engineering craftsmanship. Third place goes to Joe Angie. Radio controlled engineering and craftsmanship, second place, class fleet boat, an American type submarine, Frank Ricucci. Frank. I hope you won that award before it sank, Frank.
Frank, pose right here.
Hey, Bill.
Second place, RC Engineering, Frank Ricucci. The first place award is for another German U-boat. This one a Type 2C, and the award goes to Chris Klepsch. Chris. Best in class radio controlled engineering and craftsmanship, that's Chris Klepsch. One more award to give out. Each year we give a bottom gun award to who we regard to be one of the best sub drivers, probably the best sub driver of the season. And this year that award goes to Rich Kohlbrecker Jr. Richie. Your dad's been bottom gun a couple of times. Do we call you Bottom Gun Jr. now, or do we just call you the new bottom gun? Richie Kohlbrecker, our bottom gun, Sub Regatta 2002. And now the event you've all been waiting so patiently for, the raffle ticket numbers. Everybody pull out your stubs, your ticket stubs.
Touched by human hands.
Dave has got this thing start shooting some pictures of it. We've all seen the visible. Support Washington. That's the only way it can get it can be supported. What time did you finally get it back? No, of course, we're double A. Try to see how much clearance you have.
With critic too.
Nine-volt battery inside of the sail here. I got a wireless video camera in the sail of the 688i, and it's on right now. It's got a 9-volt battery inside of the sail here, and you're looking at the lens that's behind the lens, little filter. And if we fine tune it just a speck, you might be able to see it. Here's a picture of you in the camera. There we are. There you are in the camera. It's taken from my submarine. Ta-da! Momentarily. Now this is just a manual switch, and that turns off the signal because there's only a 9-volt battery in here, and I want to switch. It's on. On is this way, so that in case something hits it, it'll stay on, and off is this way. There's the drive motor there, and the fan cool motor, and you can't see the 3-to-1 reduction gear, which is in the part that's not transparent.
Hi, I'm George Perchenko from Rochester, New York, and I brought my in-process Fulton Nautilus today. We had this at the show last year, but we didn't have any of the features operational. I've got it almost ready to go. We're just ballasting it out and trying to get some of the foam in place, and I think we'll give it its maiden run today. We're running it off a 4-channel system right now. It will have a ballast tank, but I don't have that set up right now, so if it'll dive at all, it'll have to be as a dynamic diver. We'll see. I don't know how much power we're going to get out of it. I've got a unique linkage system in the back here to control the very unconventional rudder dive plane assembly that Robert Fulton invented, and I'll just move the dive planes up and down, and there's the rudder. There's the dive planes again, and the rudder. I had to incorporate a telescoping rod system in order to fit this all into the narrow slot that I have to go through in order to get the top on. Since I don't really care much to have visible seams, I try to keep everything hidden. So we'll just move everything around a little bit. It's been a real joy trying to cram everything in here. The motor's up in the top section, and it only clears the back of the watertight compartment by maybe a ½ inch or less. And it's impossible to see inside when things interfere with each other. This is a homebrew watertight compartment, and it contains only the electronics and the servos. Any other features, the motor and pumps and anything else, will be incorporated in the sub body itself. And I intend to use this watertight compartment in various subs, and each one will have its own unique propulsion and diving system.
Yeah, linkage slick right. Oh, okay. No, I'm just. Otherwise, no.
Okay, we have an electric gearbox in there made from an old servo, and I just have to do this manually now because I don't have the electronics to drive it. See if I can bring it up. I should have had a switch for this. And there's a sail in the up position. And reverse polarity. See if we can drop it down. And sail down. This will be driven from the transmitter at some point in time. Although I have my doubts about diving with that sail in there, it's going to trap a lot of air. I don't really know what Fulton was thinking when he designed this thing. It's been a fun project to build, and we intend to have a lot of fun with it. That is a Robert Fulton 1801 Nautilus. It has a man-power propeller and a sail power surface running, and at the moment no rudder control. There's a hard at port. Full speed. Running maximum motor, direct drive, swing 3.5-inch 4-blade prop with a sub-tech speed controller. Back it into the beach here.
You can't get it, I can walk out. What's the sail made of?
Well, I think I'm going to plunk that sail back down.
You know who I am? I'm David Merriman, your worst nightmare. I also build model submarines. Down here, this is a model submarine demonstrator for torpedoes. This is the end game. We're talking about small scale torpedoes, 1/96 scale. This is what ultimately we want them to look like. The object of the game is to actually make them practical, mobile. Here we have some cutaways of the systems used to launch these torpedoes and a good look at how the torpedo itself is a reservoir for gas, which when expelled from its nozzle sends the torpedo on its way. This is a 172nd torpedo. We'll be discussing its launching system here in a moment. What we're looking at here is a breadboard, a mock-up of an air ejection system, which is used, the air is used in compressed form to eject the weapon from the tube. The process of ejecting the weapon also frees its nozzle and permitting the gas, which is stored within the torpedo, to expel through the nozzle, sending it through the water. We have achieved ranges of up to 70 feet using this system. You're looking at the charging fittings here, which charge the onboard weapon. This is the firing valve assembly using clippered valves and a cam-operated switch, which when operated from a servo, a single servo, can give me as many shots as I've designed lobes into the cam. So as we rotate this ratchet assembly around, the cam hits a valve. The valve then discharges some gas into the breech end of the torpedo tube, forcing the weapon out of the tube and on its way. And now we're ready for the real thing. Here you see a practical 6-tube torpedo launching system I developed for the 172nd Thor Alpha. It is a practical launcher, pretty much along the lines of the demonstration unit I showed you, though it differs in that I use stored propel gas instead of compressed air. The advantage of the gas being that I have more energy in liquid form than the air does under pressure. This necessitated the change from clippered valves in my firing valve assembly to modified straight air valves whose seats can take petroleum gases such as propel. In principle, it's the same as the other unit in that we have a cam-operated sequencer. Each lobe on this rotating cam intersects a plunger assembly on each discrete firing valve. Each firing valve goes to its assigned tube. As the ratchet rotates around, the lobes in turn hit their respective firing valve, launching a weapon. That ratchet is operated through this push rod, which when hit by the single servo cycles a lobe over its respective firing valve, launching a weapon. For each depression of the push rod, a weapon is fired. In this case, we have 6 lobes on the ratchet. We can launch 6 weapons in sequence. I took the standard Thor 172nd Alpha kit and tricked it out with torpedo tubes. Now, the actual torpedo tube mechanism sleeves inside into this slightly larger bore tubes which penetrate the hull. Those tubes, incidentally, are pieces of K&S brass tube which were then snipped off and ground flush with the contour of the submarine. It looks like a very difficult thing to do, but once you make a jig to line them up and you install the tubes, only after all the adhesives are cured hard do you come back with a cutoff saw, remove the excess, and achieve the flush fit. Of course, that gives you these teardrop-shaped depressions, which give quite a bit of character to the subject. The scoops, which basically is a characteristic unique to Soviet design, are used to lessen the burden on the main surge pumps. Well, not main surge pumps, but the condenser pumps, which have to pump the residual steam from the propulsion plant and reduce the water. The scoops provide some pressure head to those pumps so they don't run hard, consequently don't make as much noise as they would if they had to move the water dead in the water. You got a scoop port and starboard, and add quite a bit of flavor to the subject. All right, we're looking at the ass end of the Alpha, the propeller. We see what appears to be a vortices attenuator, and this is a characteristic which we've seen on Kilos and other Soviet submarines. Interestingly, the main wheel has a left-hand pitch to it, which was revealed in other photos of Kilos. The little outboard propellers you're looking at are variable pitch. The intent is to get them to zero pitch as they're represented here to offer the least resistance while the submarine's in motion. It's surmised that they are used for maneuvering only and perhaps as an emergency form of propulsion in the event of a main propulsion casualty. Installing the torpedo launching mechanism into this hull is a rather simple operation. I took care as I created the system to ensure ease at the site for maintenance and operation. First, I take the hull halves apart. As you can see in the upper hull half here, we look inside, we can see the foundation tubes in which the torpedo launcher will sleeve into. To install the launching system, I first put in a guide pin or tube here, which permits me to start registration of these tubes within the foundations. So once I have that in its respective foundation piece, it's a simple matter to slide the affair in. And at this point I have to put my whole hand in there. I'm grabbing the harness of tubes, remove the guide tube, and I finish slamming the unit home like so. So that's all there is to get that in board. The only other thing to make up is the push rod used to fire the tubes is to secure it within its little foundation there. So I make that up with a rubber band and we're all set. Loading the torpedo tubes is a simple matter. It goes through the muzzle end. I first start each weapon. Now there's a very tight tolerance here. Even a grain of sand could interfere with a smooth motion of the weapon within the bore. So you take care to clean things between shots. All right. So with the torpedoes started, I ram each one home, setting its nozzle against a gland which is in the breech end of each torpedo tube. And I can feel that, and I apply a slight pressure to get it on the gland. There we go. So we have 6 weapons installed and on the glands, and now we're ready to charge the weapon system as well as the launcher. We have a common manifold here. You'll notice that there's 7 Schrader valves. These are used to charge the center one for the torpedo impulse system, the launcher. The remaining 6 are for each individual weapon. All right, we're going to use Propel to both charge up the launching system as well as charging up each torpedo using the Propel. First, we're going to bang up the impulse system. Like so. And then each individual weapon will be charged. All right. We are now charged, ready to button up the model and go on patrol and sink American ships. I'm installing this big brick of flotation here, which is needed to counter the weight of the systems. It slips in there, like so. The manifold sits within this depression and is secured simply with a couple of pins, like so. We're performing a brief test here of the launcher system. 1, that was an empty tube, weapon, empty tube, weapon. There we go. What we're looking at here is the push rod, which makes up to the launching system push rod. This is coming off the servo within the WTC. You can see its operation here. And it's a simple matter to put the two.
Big brother is in the water.
Yankee imperialist dogs, clear my boating site. Ready to launch? Hey, keep the dog stay out of my patrol area.
I started working on this model 4 or 5 years ago when they first were working on raising the model, or the real submarine Hunley, and probably got started too soon because I had to change my plans several times as they found out more about the real sub. The bow was different than what they thought from the old drawings. The bow was actually curved. The dive planes were a different shape. They're more water ski shaped, and there were little fins in front of the dive planes. The plates are not overlapping like they thought. The plates are actually butted, and the rivets are flush, so you can't even see the rivets on the real sub. It's probably the first ship that used a flush riveting system. The rudder is quite unusual in the way that it worked, and this is the way that the real submarine's rudder worked. By just swinging a rod back and forth and a sliding plate, that there's a notch cut in that rudder, it moves the rudder left to right. So instead of needing two push-pull rods, they only needed one rod to swing left and right to work that rudder. Pretty ingenious for 1800s technology.
My name is John Geib. I'm from Reading, Pennsylvania.
This is Matt Thor's new permit.
Just the basic WTC3. I have high-tech servos. I'm running Skip Assay's nickel metal hydrate batteries, Thor throttle control, and APC4 from Subtech.
Hi, Rick Allenson at the Sub Regatta 2003 in Rhode Island, and this year I brought a new monstrosity. 2 years ago I had a smaller controller and it grew into this thing. What this is a touchscreen controller which will allow you to control several functions of any sub. This is a Sub Commander control box, and I've designed it to run a sub with missiles and torpedoes and any number of extra functions. This screen is a touch screen, and you can select your missiles by touching the touch screen. Brings up a panel for your missile selection. You can then launch them with a touch of the screen. You can set your launch depth as well. Then you can return to the main menu. You can select your torpedoes from either here or this menu here and do the same thing. You can select independent torpedoes. You can load them and tell the submarine that it's ready. You can also fire them independently. And then again, back to the control screen. Go to pre-programmed maneuvers. Special functions in here. It gives you lost signal, critical warnings from your boat, low battery, CO2 is low, there's a flood. We'll give you the data as well, heading depth, dive angle, speed, and telemetry, and also your main battery voltage. There's a low baud rate modem piggybacking on the audio frequency of the video transmitter in the periscope that gives me this information. This is a video screen to receive your video from your periscope. It has superimposed crosshairs, and in the top corners it says dive angle, heading, speed, and depth. and we'll give you any of these warning systems across there directly from the boat. It's a redundant system to copy the audio modem, and you can plug in headsets, virtual goggles, or video cameras to receive that, record it from the side ports here. This is a video receiving panel here. You can select any one of 4 channels. And then down here is a Futaba 9-channel PCM computer radio, synthetic frequencies. And you can select any frequency and edit your patterns of movement of the servos, fail-safes and such. And in the heart is another microcontroller that interfaces the entire system together. And here are some nice little arming switches. We go to the missile deck. We need to arm the missiles. Now we can fire them.
Yeah, but Rick is still too. That's his first sub right there. He built it last
Let's make it go.
Get a good break. Oh, hey, look, I need a battery.